Okay, number 2. We have a solution of HCl as a pH of 0.6. So that means that we've put some HCl in. It's dissociated completely because we know it's a strong acid. There's also water in here, which means that there's always going to be H plus and OH minus ions. Now, it says the pH is 0.60, so we know that the concentration of the H plus ions must be 10 raised to the negative 0.6. And if we do that out, we know that that's a 0.25 molar solution. Now, into it, we're going to add 1 gram of NaOH. So we know eventually we're going to have to go to moles out of this, but let's just think about what's happening. In that beaker, the NaOH is going to react with the HCl to make NaCl plus H2O. We want to find out what the pOH is, so how much OH ions are in this beaker after the NaOH neutralizes some of the HCl, after this reaction happens. So in order to do that, we need to find out how many moles of each of these are in there. Now, really, the Na and the Cl, they don't matter to us. So if we do Na plus OH minus plus H plus Cl minus, if we do the full ionic equation and cross out the spectator ions, we get H plus OH minus makes H2O. That's really what's going on in any neutralization reaction. So the question is, how many H plus ions are in the beaker? What moles? How many moles of OH am I adding? And then determine which one is limiting and which one is excess, and figure out what's left in the beaker after the reaction. So we'll work on the H plus first. We know we have 0.25 molar, and we know it's 250 milliliters, which is 0.250 liters. So the number of moles of H plus ions is going to equal 0.25 molar times 0.25 liters. And for that, we're going to get 0.0625. So there's 0.0625 moles of H plus ions. This is really the moles of HCl, but since HCl dissociates with the 1-to-1 stoichiometry, we know that the 0.0625 molar for HCl is equal to that for the H. Now for the OH, where is that coming from? That's coming from the 1 gram of NaOH. So 1 gram of NaOH, we need to know how many moles. So 1 mole for every 39.99 grams, and that gives us 0.025 moles of NaOH that we're adding. But since NaOH is going to dissociate, that's going to make 1 mole of Na and 1 mole of OH for every 1 mole of NaOH. So this 0.025 will make 0.025 moles of OH. Now, since this is a 1-to-1-to-1, it means it's easier to see the limiting. Whatever I have less of, I'll run out of. So I'm going to run out of the OH minus. So those are going to be used up in this neutralization reaction, and I'm going to have excess of this. So the excess, H plus, I'm starting with 0.0625. I use 0.025. So what I have remaining of H plus ions is going to be 0.0375. That's the remaining moles. So the concentration after I add the 1 gram of NaOH, it neutralizes some of the H pluses. So the concentration of the H3O plus, or the H plus, is going to be the number of moles over the volume, which didn't change. And when I do that, 0.0375 over 0.25, we get 0.15 molar. So my concentration has dropped. It started at 0.25, it's down to 0.15 molar. Now the question asks, what is the pOH after the addition of the sodium hydroxide? So we know pOH plus pH equals 14, so let's find the pH from this concentration of H+. So the pH is negative log of 0.15, and when you do that, negative log of 0.15 comes out to be 0.82. That's the pH. So the pH went up, which makes sense. If the pH is going up, it's becoming less acidic. Some of the hydrogen ions are being used up. So the pOH will equal 14 minus the pH. So the pOH will equal 14 minus 0.82, which will be 13.18. That's the pOH of the solution.